Welcome to APEC. It's January 7th, and I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Ethan Krauss will discuss Electron Air Ionocraft. Dave Rossi will provide insights and a new perspective on old physics. Jeremy Reese will present an updated UAP Technical Briefing, and Mark Sokol plans to retest the Podkletnov Impulse Generator, as well as Wayne Ojala discussing Alzofon experimental videos. We'll be finishing off the event with an open discussion and ad hoc presentations by conference attendees. So quick reminders, you can view conference replays, details, and speaker info on our website at altpropulsion.com. Please save your questions for the Q&A session after each presentation, depending on availability of time. Please raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. And again, that's after the presenter if we have time. I do have a special announcement for everyone. After 2 years and 47 conference sessions averaging 8 hours each, this will be our last scheduled session of the APEC conference. When Mark Sokol approached me to moderate this conference 2 years ago, we saw it as an opportunity to bring the entire community together in a single place to discuss emerging propulsion research and share ideas and paths to success. 2 years later, we've achieved that goal beyond our wildest expectations, with multiple presentations by virtually all the leaders in this field and major advances by experimenters in the community. Simply put, our conference has vastly outpaced the rate of progress being made in this field, and it's time to take a long break for the entire community to catch up. In our very first conference session, Ron Kita called APEC the Woodstock of anti-gravity, bringing together over 70 years of knowledge, research, and experimentation in a single venue. This conference has been a tremendous milestone in emerging propulsion research, and I want to thank everyone involved for their support and participation. Our plan is to maintain the website, WhatsApp chat, and other online forum features indefinitely to support continued research and collaboration. And on that note, I want to genuinely thank each and every one of you for the tremendous work that you've done, not only in showcasing your own research, but also in honoring decades of work by others, many of whom are no longer with us. Thank you, and I genuinely mean that. So let me introduce you now to our first guest. Ethan Krauss will discuss the first self-powered, ion-propelled aircraft in history that can both take off and fly with its power supply on board. It's covered under U.S. patent numbers, and I will put those in the notes, which describe ion-propelled flying machines that carry their own power supplies. Ethan is going to describe why his device is orders of magnitude more efficient and powerful than anything like it for its weight. So without any further ado, I want to welcome Ethan to today's event, and I will hand things over to him to get started.
The thing I've been doing for the past 23 years full time is ion propulsion, in air ion propulsion, and I had this idea. I was working on jet engines a long time ago in the 90s, and I thought, wouldn't it be cool if if you could make an electronic version of that? So I was talking with the manager, and he said, well, these engines that go up to about 40,000 RPM, and that's about, that's as fast as they'll spin. And I thought, wow, if you had an electronic one, then it would be, theoretically, it could be much faster under certain conditions. So the idea, I kind of put the idea off to the side for a while, and I built a device that had a series of electromagnets, cylindrical electromagnets. And I was talking to my younger brother, who's a professor at Brandeis, chemistry professor, and he said it would probably take a lot of energy to ionize air enough to make it reactive, to the magnetic fields. So, and then I was looking on the internet, and I found the Seversky Ionicraft patent in video, and I thought it was amazing. I thought, is this thing even real? You know, how does something fly with no moving parts? And it was way back, you know, that was back in about the year 2000. I don't think I'd ever seen the ionic breeze air cleaning device back then. So I tried to copy that Seversky patent, and it would blow a little bit of wind, which was interesting. And I got to blew a candle flame with it using a huge power supply. And then I finally ended up making one that could fly with a little triangle made of aluminum foil and with round holes in it. Right, I cut 10 round holes in a little 4 1/4 inch piece of aluminum foil and put little needles shaped wires hanging over those holes and attached a high voltage supply. And at first it wouldn't fly, and then I was getting frustrated with it, and I thought, well, you know, maybe if I switch the wires, it probably won't work, but if I put the negative wire to the emitters, maybe it will fly then. You know, it didn't sound very promising, but I switched the wires around and threw the switch, and the thing floated up near the ceiling, you know, with 2 tether wires, you know, two electrical wires. So that was very exciting. That was in the year 2000. And then after that, I took the transformer out of this huge, it was one of those old, the power supply was a huge big screen TV, you know, the old fashioned kind. They weigh about 150 pounds, you know. So I got the flyback out of that, and I found a little circuit to run the flyback. And then I switched to a smaller flyback. And finally I had this power supply that was inside of a box of playing cards. You know, it was just the typical flyback powered, you know, system. And then, but it took quite a few amps to run that, you know, big batteries. And then I found out that you don't really need so many amps to run those things. You need, you know, the air is more sensitive to higher voltages, but you don't necessarily have to have a lot of amperage. So with low current, you can use low wattage, right? So you get more efficiency that way. So I'm going to rewind a little bit real quick to where I was talking about the little flying triangle with the needles over the holes. I found out that flew with more thrust with negative polarity. When you have an Ionicraft with needles for the emitters, and you put them right next to the collector surfaces, and you know, if you have a high current power supply, the negative polarity does give more thrust. And that was verified by Professor Adrian Aeta and some other people. But on the other hand, if you have a ion propelled vehicle with linear emitter wires, real thin, you know, emitter wires, I think everybody here is familiar with ion lifters, probably. Tim? Everybody is? So obviously Tim is tops on that. But anyway, so then you want the positive emitter wires tend to work better. And the higher the positive emitter wire is, the less current you get, the more thrust you get per watt. And that's also been verified in some scholarly papers. But they didn't do as many experiments as I did. So, you know, I you know, searched down that path quite a bit. So also other ways to get, so I'll rewind again here back to, I had gone with the flyback power supplies like people are tending to do nowadays. And then I found that you could run with lower current. So I looked into ignition coils for other sources of high voltage. And I went, you know, obviously automotive ignition coils, the old fashioned ones, were big and heavy. So I switched over to motorcycle ignition coils, which are, you know, epoxy insulated. And then I found some that were, it actually had a core that was, you know, ferrite core that ran at a higher frequency, and those were smaller. So I disassembled them and started making my own and grinding my own cores out of ferrite. And then I looked into power supplies, like, and in the old laptop computers, before they had LED lit screens, they had little high voltage transformers, the little strip. I don't know if you guys are, who all seen those, but any electronics person would know about that. And those little high voltage transformers are very small and light, high frequency. And when they're connected to a voltage multiplier, you get real high voltage DC at low current, which is what we need, you know. So, so I went to that step, and I was disassembling those and making my own versions of those. So, you know, it went from a huge, heavy power supply down to smaller and smaller, higher frequency systems. And then I found a way to make a voltage multiplier that's just a single line of capacitors. It's really not all that different than a standard voltage multiplier, but so how am I doing so far? Is this educational? Good. Okay, good. This novel, semi-novel voltage multiplier, you put all the capacitors in a row, right? But electrically, it's pretty much the same as not the same, but it's similar to a Cockcroft-Walton half-wave voltage multiplier. Now, a full-wave Cockcroft-Walton voltage multiplier has many more parts, right? And each part's losing electricity. And it's better for if you want higher currents, but it's not better if you want the most, you know, a high voltage source that's extremely lightweight and efficient at low current. So what I found is that if you want to make a ion propelled vehicle fly, it's going to work better. It works better. A VTOL version especially works better with a half wave multiplier. And furthermore, if your multiplier is reverse polarity, so you put all the diodes so they're facing towards the base of the multiplier, then you end up with your inverter being charged at a positive polarity, right? And here's the way I think of electricity too, is that electricity is the flow of electrons and energy, right? Through and around a wire. I don't think anybody would argue with that. But, well, most people wouldn't argue with it, hopefully. So if you put wherever, the reason that coronas are created, another thing, people call a corona wire because it tends to produce a glowing, you know, if you turn the lights out, you can see it glowing in the dark. But whenever you build an ion propelled vehicle, if you see anything glowing in the dark, it's really, generally speaking, it's a power loss. So what you want to do is insulate anything that's glowing. You put the emitter wires up real high, and you use emitter wires that are only microns in diameter. And then you can get rid of most of the corona, because corona is caused by the de-excitation of oxygen molecules, mostly. Depending on, at higher currents, you have some nitrogen things going on, but that's at very high currents. So at normal power levels, you have you know, when oxygen likes to grab extra electrons because it's electronegative, and naturally, so it grabs up electrons in the outer orbitals of the molecules, and and when it grabs electrons, it kind of, you know, swells up with extra electron, and it doesn't give off any photons. But when it loses an electron, it gives off a photon, and that's why you see that glowing, that corona, is because it's oxygen molecules de-exciting, losing electricity. So it's possible to make a vehicle that flies with by just adding electrons to that oxygen. You don't have to reach the ionization potential that you would, like with a xenon thruster, for instance. You can get super efficient ion propulsion by just adding electrons to oxygen molecules. So anyway, so I've gone from history of it, and I started going into the physics of it, right? More on the theoretical end, but it's not really theoretical. I've double checked all this stuff. So with some, you know, serious people. So it's correct, and it makes sense. And so what you want for an efficient vehicle, to go fully into talking about how the thing's made, how to get more efficiency, thrust per watt, and so on, more power for the amount of energy you put in. People usually speak in thrust in terms of newtons. You're supposed to do that, but I like to speak in terms of grams because I use all gram scales to measure everything, right? And why bother to convert it, just an extra step. So, what you want is the basic specifications of mine are, after many iterations, like a ridiculous number of experiments, I found that the most lift you can get from a collector surface is with a collector that's teardrop shaped from a cross section, and that's 4 millimeters wide and about 12 millimeters tall, right? If you have a taller collector, you get a little bit more thrust, but it weighs twice as much, So most of the thrust comes from the front curvature of that collector. So I had good luck with 4 millimeter by 12 millimeter. When I went to different dimensions, the results weren't quite as good on a thrust to weight basis. So, and then the emitter wires, I kept getting them thinner and thinner. And I found out tungsten is the only wire you can make really thin that you can work with. So I use tungsten emitter wires, and I use a horizontal support for those. They're actually glued, the tungsten emitter wires, to a special support, horizontal support. They're not freestanding emitter wires like on a lifter, right? On a regular lifter, right? You just take regular magnet wire and you strip at least the bottom of it off, maybe all of it, and you run it between the posts. But on this thing, you have a special filament, high, no stretch, high temperature filament, and I glue the emitter wire to that filament. The emitter wire is crazy thin, it's like a cobweb almost, but made out of tungsten. So with that setup, you can get a lot more voltage pressure with a lot less, with very low currents. And the collector on mine's very lightweight per foot, per meter, however you want to look at it. So the basic vehicle, the one that flew vertically, lifted its power supply for almost 2 minutes, has about 59 feet, or almost roughly 20 meters of collector, concentric rings for the collector. I mean, if you took them all out and straightened them out, they'd be 59 feet, something like 20 meters long. And that only weighs just a few grams for the actual collector part. And then the frame that holds those collectors up is made of boron filaments, which is it's like a rigid wire, but it has hardly any weight at all. And so I have these like spoke-like wires that support the collectors, and they're non-conductive, at least on the outside, and they're held by support filaments. So that gives a very lightweight collector, and then the emitter wires, these that are 15.2 millimeters tall, which is about it's like 6.5 inches tall. Well, actually 6 inches tall. Lifter has like 2 centimeter. It depends on the version, but much lower. Standard lifter has low emitter wires. People would buy a power supply and then with some good current to it, and then they hook it up and they start putting emitter wires lower and lower because it gets more and more lift, right? But the thing is that it takes more current more wattage per gram of lift that you do get. Is everybody still there? The pictures are changing around. Okay. So it's more efficient to have the emitter wires higher, even though there's less overall lift per foot per length, unit of length. You're getting, you need to get it needs to produce a lot of grams of lift per watt in order to be able to not overwhelm the lithium polymer batteries, because that's kind of like the weak link, right? Is those batteries. are those batteries. So you got your batteries, and you got a little transmitter, or I have a buck converter, batteries, buck converter, which is a step down regulator, and then you have your a receiver, and then that drives a throttling MOSFET and a MOSFET driver, and that goes to your little transformer. The transformers I use are described in the patent. I found that if you have a transformer that's very low profile, drum shaped, like a shirt button, like a little bigger than these shirt buttons, right? Between 7 and 14 millimeters in diameter and about 3 millimeters tall, you can wind a transformer like that and get very, very high efficiency levels and very high voltages for low current, applications like this. A lot of thrust per weight, and a lot of power per weight. So I run that into a 20-stage voltage multiplier. Like I said, it's got all the capacitors in a row, spaced at intervals, and that if you have a shorter voltage multiplier, if you look at it with a Corona camera, I don't know if everybody here is familiar with the Corona camera. Everybody's familiar with IR camera, probably, right? Like IR camera, you see, heat, infrared, and those are very useful for telling where you have power losses in the circuit. But there's a Corona camera, which is usually used for looking up at power lines and seeing where there's a part that's starting to give off Corona. And you can see, if you look at a ion propelled vehicle or a lifter with it, you can see any spot where it's giving off Corona. It's much more sensitive than just looking at your vehicle in a dark room. So I found out that a voltage multiplier that is short and stubby builds up a big ball of Corona on one end and on the other end, right? Especially on the negative end. And so what happens is if you make a longer voltage multiplier, the electrons aren't going to be migrating, because from the one side of the voltage multiplier to the other. Also, you could have a long, thick, well-insulated, output wire, but it doesn't work as well because you want to save every bit of electricity you can, right? Every electron you can to make these things work. So, are you still with me, Tim? Huh. I can't hear anybody. Okay. Well, you hear me, you guys? Okay, good. Okay. So I've gone into some pretty heavy details here. I'm trying to be, absolutely clear about how everything works. You got this long, thin voltage multiplier, and you run it between the emitter and collector surfaces, right, which are 6 inches apart, emitter and collector. And you don't want any of that high voltage circuit to be shorter than 6 inches, because all the power is going to go to that point. All that high voltage will look for the path of least resistance. So you make sure that your voltage multiplier runs all the way from the emitter to the collector surfaces, and then and then I have my inverter on top of the vehicle, because I found that a reverse voltage multiplier is more efficient than a forward biased one, a positive voltage multiplier. So those are the technical details and some of the history of it. It's 23 years of stuff in like 10 minutes. So it'd be nice if if anybody has any questions. Otherwise, I can keep going about this, but so let's see. Oh, I see somebody gave me a nice comment. That's nice. From Tom Gazillo to everyone question. From Rick to everyone. Oh, do I have diagrams? I have in the two patents on my Ethan Krauss YouTube channel, there's about 40 flight videos of different versions of these things. One of them shows the transformer close up being bench tested. And there's under all the videos, there's patents and they have diagrams of everything. So, so anyway, oh, thank you. Thank you for putting that out. I appreciate that. So, oh, good. I have the questions up on the side now. So, okay. So I'm trying to make everything as clear as I can. This is a mainstream thing that I have. It's not a, unproven or something. This has been flown in front of many people, many very serious people that, can't be doubted too easily, And somebody mentioned about space. I have a big vacuum chamber in one of my shops, and it's pretty big. It's bigger than a coffee table, round those outdoor coffee tables. And I put a vehicle in it to test it, and the vehicle is almost as big as the chamber. And so I had to turn the vehicle on its side and get up in the chamber with it to plug the battery in, which, with all that voltage and the weight of the chamber and everything, it was, quite a bit. Oh, okay. Somebody mentioned, do I use balsa wood and aluminum? And no, I don't. Aluminum foil is quite heavy. When if those wings, if you stretch them all out, there'd be 59 feet on the smallest version that carries its power supply, and 59 feet of foil comes out to be quite a bit of weight, 20 meters of foil. So what I use is different thicknesses of aluminized I used aluminized polypropylene. Distance to collector between collector and emitter, I mentioned before, is 15.2 centimeters, which is about 6 inches. Photos are, I don't have a set up right now to show a presentation along with my speech, but Ethan Krauss YouTube channel, will show everything you want to know. And plus there's a website, Electron Air LLC.org, that has some more details. But somebody wants some hard numbers for voltages and thrusts. The current voltage multiplier, the current high voltage systems, when they're bench tested, they output 42 kilovolts, which is it makes a 14 millimeter spark. And they draw about, the ones that create enough lift to lift themselves draw about 1.5 amps. But that's on 100% throttle. So the vehicles take off on about 40% throttle. Somebody said they uploaded the patents. Good. I don't mind if inventors make this thing. I'm not trying to stop anybody from experimenting with ion propulsion. I would love to see some people replicate what I've done. It's just if somebody else does it and then they said, look, I'm the first one ever, and take my stuff, and then they make $50 million and they don't share it with me, that's not very nice. So somebody asked if I was exploring different waveform shapes and frequencies. Yes, you want to get the best frequency for a given transformer, and generally the higher the frequency, the smaller the transformer that you can use, and smaller capacitors. But the thing is that ferrites have a limit as to how high of a frequency they will. They have an ideal frequency they work at. So you can only go so high with the frequency. So the last transformer I measured was running at 380 kilohertz. But if you, like I said, you got to adjust it until you get the most throughput. So and you do that by changing capacitors around and inductors, but mainly capacitors. So Oh yeah, somebody asked if I got some thrust in the vacuum chamber. I left you guys hanging on that. So I got the thing in the vacuum chamber, and I didn't expect it to produce thrust in the vacuum chamber without a propellant, so I added a propellant when it was in the chamber. And I had a little tube going in from an oxygen cylinder. First, I tried it with SF6 and outside of the chamber, and it actually got less lift. It didn't, which was somewhat expected, So I switched back to oxygen as a propellant, and it got a little bit better lift with pure oxygen, being distributed over the top of the vehicle. So then I put it in the chamber with repellent tube running in through the bottom of the chamber, but I tried it without even pumping the chamber down, and all the lift went away, because the chamber blocks the sides of the vehicle, right? The vehicle fits right in the chamber. The sides are all blocked. A lot of the air on this thing comes into the sides. So when the sides are blocked, and the top of the chamber is covers the top of it too. So there just wasn't enough flow for it to fly in the chamber, even when it wasn't pumped down. So I'm going to have to try the vacuum tests with a smaller vehicle. So boron, tungsten, thanks. Somebody said they're loving the talk. Thank you too. What are you planning to do with this? Somebody said. Yes, I'm going to commercialize it. I started off with making aluminized the collector surfaces out of aluminized polypropylene. The inner rings are thinner polypropylenes, and the outer rings are a little bit thicker because they have to be stronger. And it varied from about 4 to 8 microns in wall thickness, which is very thin. It saves a lot of weight. But the problem with the aluminum is after a couple of weeks, there's too much aluminum oxide, and the craft wouldn't fly anymore, because aluminum builds an oxide when you put it out in the air. So then a few years later, I ordered some polypropylenes covered with silver, metallized with silver, because the silver doesn't oxidize. But even pure silver will tarnish after a while, which is a reaction with hydrogen sulfide in the air. So I tried to make containers for them to protect them, but they still are tarnishing. So the next step is to to put a few 100 milligrams of gold on the collectors, and that's going to be the next. The next vehicle will have absolutely reliable collector surfaces. And somebody wants to know the details on the power supplies. I just went over them the first part of the speech in pretty good detail. It's a push. I use push-pull. I don't like flybacks. It's okay to get a flyback transformer if you modify it, for like off-board power supplies. But how much of the power dynamics do you describe the geometry? Let's see here. I'm reading a question. Most of this isn't my power supply. A lot of people assume that ion propulsion requires a lot of power. There's not so much true anymore. You can do it with lower power. Just have to use high voltage at low current, and then the geometry of the structure is the main thing. You want those incredibly thin emitter wires at a very high distance, and you need a lot of collector surface to get lift from a small power supply. Great importance. The main thing to know is that this device really works, and I've shown it to all kinds of officials, and it follows physics very closely. This is not a physics, a device that breaks physics in any way. It's,
Yeah, well, and if I could offer a thought, I've read that Ionicraft have a very high ISP also, right? So I think that was one of the things, and I think you'd put that in your patents. That
I wanted to mention, about that is that it's recently been proven. Somebody made a space thruster with high voltage instead of like 3,000 volts, which to me is not really high voltage. It is, but instead of 3,000 volts, they made a space thruster with 30,000 volts, and it's much more efficient. So much better ISP. So the speed of those particles is proportional to the voltage. So this has a lot of possibility for a wonderful ISP in space. But to make it work in a vacuum, a person has to either add propellant for that in that case, or they have to have millions of volts. So what would be the expected ISP in a vacuum? The worst it could possibly be 10 times better, but we have to get enough thrust too. These are other issues. Those things aren't proven yet. I still have to do vacuum tests. How high voltage do I use? 42 kilovolts is typically, but I'm working and experimenting with far higher voltages. Let me see here. My wife was pointing out some questions to me. Avalanche energy uses similar voltage in the current. Let's see here. 12 electrodes because they only produce a small amount of energy. I don't really know what that. I don't understand the question there. Anyway, but so what is the thrust to weight? Somebody asked me. It's greater than 1 to 1. It's about 1.2 to 1. It depends on the vehicle. See, in order to fly with a steering system, I had to put a huge extra outer ring, and which is segmented, right? And with 4 quadrants. And I alternately energize, like I de-energize one of those outer quadrants, and it will lean in that direction of the de-energized quadrant, right? But the outer ring weighs more, and and it takes more power to run the switches. There's 2 little switches that are used for steering, onboard switches. So by the time you factor all that in, then it's like the lift is then like 1 point, just over 1 to 1, 1.1 maybe to 1. But without the steering system, it's more like, 1.2 or 3 to 1. Well, maybe not 1.3, but can lift a little. I've carried 2 little propellant tanks before on board. They're very small, but I didn't understand the question about the internal combustion engine and the 12 spark plugs, but just a comment. Okay, that's cool. So yeah, I am available to work with universities. The next steps with a business plan, Charles asked. I'm the patent is available for licensing, and basically I'm looking for investors and people that will donate I got to buy that gold coated polypropylene, and pay some people to help me, because it's all me sitting there doing the fine work, and I can only do work so fast, and so it'd be nice to have a team working on it with me.
Well, now, Ethan, if I could jump in, and it's probably not fair because I'm moderating, but have you ever considered using, because you have functional ion propulsion, have you ever considered using an offset of some kind of basically helium balloon, right? And creating some kind of a dirigible, and then you could, in essence, you could create kind of a drone where all you would have to worry about is the propulsion, and then you could have just neutral buoyancy from the helium.
Right. Well, I have done that, and the first guy to do that that I know of was in 1977, all the way back then, when I never heard of this stuff before. And he made something for the military that flew around in a hangar, but it was quite slow, But that's pretty amazing. All the way back then, he was doing it. You can lift anything with a balloon, with a blimp, but it's not as cool as. It doesn't have as far-reaching, as a heavier than air thing. Potential is, excuse the pun, is a heavier than air vehicle. So, back in 2003, I think it was, I made a balloon that's sort of flattened shaped, helium balloon, sort of flattened shaped rocket looking thing. I made it with clear balloon plastic, and I hung a power supply under it and a big lifter device, and I could connect up the power wires, and it would float up to the ceiling with the power supply on board. And then I would disconnect the wires, and it would come back down again. But it wasn't very fast. And I decided then, I thought, I'm going to make one with onboard power. I kept trying to do it, and it wasn't clear whether it was possible at first, and eventually I got that to work. So it will be much more efficient very soon, because right now about half of the power is used up in the transformer, because I have to really crank it up a bit, to get it to work well, especially at the end of the flight. And the transformer is running kind of hot. It's on the beginning of the saturation curve for the ferrite. So, that's once I get rid of that, make a little better transformer, change a few things, it should fly more like 4 or 5 minutes instead of 2 minutes. Somebody said, well, on flight, does the prototype react to wind resistance in ordinary and unexpected aeronautic ways? It did accelerate a little faster than I expected into the wind. Well, yeah, into the wind somewhat, but it's very sensitive to wind. And so, I have to wait for a day when it's not windy to fly it outside. But I'm looking forward, I expect it to be improved soon. So, and I do see the potential for much stronger thrust as well. Somebody asked if I'm open to visits. Yes, I am. Anytime, just give me a call and set something up, and people can come see what I got. Now, this month, my vehicle I have is all beat up. So it's, it's not going to do any shows this month. It'll be like next month, right? And I'm waiting on a quote from the guy with the gold coating machine, but I will then be showing it to everybody, So again, yeah, somebody says he's not sure it'll work in a vacuum, since it is using ions, not electrons, to generate thrust. They probably didn't hear I mentioned that in a vacuum, on the vacuum model, I add propellant to it. So it's the same as the ion propulsion, as a NASA ion thruster, but it uses much higher voltages and optimized geometry and low weight. So is the voltage on the emitter constant 0 hertz, or is it pulse? It's pretty constant. It has a slight a ripple, but it's pretty much constant DC, super high voltage, very low current DC. It's kind of like, when you rub your feet on the carpet and you get a spark and you touch a doorknob. It's very low current. It's not really terribly dangerous, but it's it's DC. And somebody asked if there's a benefit to using pulse voltage. Like a few weeks ago, I would have said no, because I used to make 555 little clock circuits years ago, and I used pulses, and it didn't show any more efficiency with them. But the actual answer is yes. It gives a little bit more efficiency to pulse the current, because when I take off on the vehicles, when the vehicles used to take off about several months ago at 40% throttle, that comes out to be take off on 40% throttle, but when the batteries that charge up to 8.4 volts got down to 6 volts, the craft wouldn't fly anymore, right? So this indicates to me that the using pulse width modulation gives you a little bit more efficiency. And nothing spectacular, but it's notable. Basically a throttle, just use a throttle and turn it down a little, from a standard receiver. Sublimation provides a small number of ions under vacuum with high voltages. Yes. Yeah, there are things going on in a vacuum. For one thing, when people measure the currents in these things, some of it's missing. It doesn't all just go to the collector and then neutralize, and that's it. A lot of it leaks away. And when I was flying a vehicle in the early 2000s, almost a 6-foot one in a garage, my pant legs would charge up with static electricity. And I thought, there's charged particles coming out of this thing for sure. They're not all neutralizing on the collector. So, and then recent measurements, somebody found that 10% of the current was missing from it. So, I like my original experiment where my pants charged up. That's pretty conclusive to me, that some of the electrons are getting away below the vehicle. So, maybe even in a vacuum, any kind of electron beam action there is going to create some bits of lift, but any real lift, it would need to have either millions of volts for real electron beam, intense electron beams, or it would need to have a propellant added for that in that case, small amounts of propellant. Do I communicate with John Louis Nauden? I have sent him a letter once, and he responded. And he has an awesome website, and I think he does really cool stuff, and it's inspiring. He's a great person. So, but other than that, I don't know what else to say about that. Who do I get? Did you communicate with Nauden or other ion scientists? Yeah, I've tried to send letters to most people, and I'm always happy to hear from anybody. And I get inspired from everybody that works on the subject, And Tim's very inspiring with his monster flying machines. So, did I say yes? I did say theoretically, a craft with millions of volts will work in a vacuum. Theoretically, it'll produce tens of grams of lift, but it hasn't been tested yet. So, until the proof's in the pudding, since the thrust ratio is over 1, how possible would it be to use it for delivery of a CubeSat to orbit? Well, vacuum tests have to be done, and I don't really know the ISP 100% until it's done in a vacuum. I don't know if I can get enough lift for it to keep going, out of the, when the air gets too thin, because you got to start adding propellant at that point. So those things are just not known yet, and I can estimate and I calculate what it should happen. I'm not familiar with John Paul. No, airship to orbit. I am familiar with that. Yes, as a matter of fact, actually, I think it's great, absolutely great. But I don't know much about it. I specialize in just on Ionocraft ion propulsion experiments. Yeah, and experiments designed to make my device carry its power supply, be more reliable and efficient, and work on steering of it and so on. So, night vision intensifier tubes. That's interesting. I've never disassembled one before. I have one, but I kind of hate to take it apart. It costs several $100s. But anyway, it's a good idea. It's interesting. I should maybe look at the schematics online. But I don't think, it's hard to get something lighter than what I made. I made my power supply specifically for this, to shave off every milligram I could. So, and to make it as efficient as I could. So, considering live stream on YouTube, I have done another thing. Well, it's not live. I haven't considered that. I don't consider myself much of a talker. I'm more of a guy that deals with, a few equations and a soldering iron. I keep busy with that. So, but there is another program, a short one. Well, not short. There's another one with Bradley Wistance, where he asked me a bunch of questions, but this one's more in depth, I think. So even that one. So, looked into dielectrics between it can be a good thing to put a insulator between the emitter and collector, but you're adding weight, and so not really, so far the best results have been from following the paths that I've been following so far. Somebody asked, how's the steering work and how do you control charge? Charles asked, how do you control charge on different segments? Okay, in the old Seversky patents, which many of you may have seen, Seversky was the first guy to make a device with a huge external power supply take off straight up into the air. And he had a steering system that would de-energize or energize different quadrants, right? His vehicle was cut up into 4 pieces, and he would cut off the power to one side and it would turn to that side and so on. But if you do that with this vehicle, there's too much power loss because it creates a bunch of extra corners. So what I had to do was, go back to the original model that works and then put a extra ring around the outside of it. I'm skipping over a bunch of iterations, different designs, but by putting an extra ring around the outside of it and segmenting that, the vehicle was able to lift that extra ring. And then I keep the extra ring energized as well. And then I just cut off power to one segment at a time. And I have a little tiny circuit with 2 little switches, and I call them, and springs on it, I call them whisker springs. They look like little whiskers of of guitar string, right? Very thin stuff. And it makes the little it's got 2 little there's servos and there's actuators. I switched over to actuators because they're lighter. 2 tiny actuators, and they keep all the quadrants connected. They're 2 3-way switches, and all the quadrants are normally connected. And then when you want to turn in a certain direction, you shut off one of those quadrants just on the outer ring. And the way that high voltage is switched is with a tiny switch that has springs that normally they're all on, and then when it starts to move one direction, it disconnects one of the quadrants. So, and that's connected through the tiny receiver I have.
Wonderful. And I think we've got just about 4 minutes left. So I'm not sure. I'm not sure if you want to wrap things up or if you had more. Or
well, it's been a long odyssey for me, a lot of hours doing this, and just by doing it a lot persistently, I got lucky, I guess. In several different ways with it, but I'm still working on it now, trying to make it better. And I just wanted to thank you guys very much for having me, on for a visit. And it's great to see Tim in real life. It's like a celebrity, and is a celebrity, and it's just great to see people that are interested in this subject. I know you guys have been doing this a long time yourselves, or some of you, anytime anybody wants to talk about it, would like to chat about the subject, I would love to, to get it, to talk about it. So.
Well, on that note, then, Ethan, let me do this. Let me put this on gallery view, and I want everyone to give you an enormous applause, for Mr. Ethan Krauss. Ethan, you've done something. I never did this. You're the only person I know of who has been able to make an onboard power supply work. I mean, that's a tremendous achievement that pushes everything forward in that area. So. Again, I mean, it's an honor to have you on to talk about this. So thank you again, sir.
Thank you. The same to you.